Welcome to another video from Lockdown Electronics with me, Bill. This time we're going to take a look at a kit from IC Station. Now, I'll get this right, it's rather grandiosely titled the Multifunctional Instrument Production Kit. So it's got to be good with a title like that. I think this kit is the ideal kind of thing for somebody who's new to electronics, as building it requires you to use quite a lot of different construction techniques. The bulk of the kit is handled by a 28-pin beast of a microcontroller, and this thing produces PWM. It will measure PWM and duty cycle, it'll measure voltage and current, it'll measure logic state and do a couple of other things. So it's a bit of a wacky thing, and I think this kit is as much about the journey of construction as it is about the finished article. So let's, without further ado, go and have a look at what we've got. So what we've got in the kit then, all comes in a little Ziploc plastic bag. So we've got the case, which here appears to be brown, but actually when we've peeled off the backing that'll be a clear plastic case, so that's good. We've got the two chips. They've got the controller and the op amp there, the sockets, and the two 3-unit displays. We've got micro USB lead. We've got the world's smallest screwdriver. I'm not exactly got small hands, but boy, that is a small screwdriver. We've got a bag of components. We've got some instructions. I'll put a link to these. The instructions are actually alright. They're in English and Chinese on here, but there is also, if you choose to scan that QR code, there's also a website, and although it's mostly in Chinese, there's lots and lots of pictures about how you might put it together, so I actually think that's pretty good. Components, as I mentioned, and then finally the circuit board. Now, I ain't no circuit board expert, but that looks like a very nice circuit board. It certainly looks well produced. I think it's several layers by the look of the edge. Nice screen printing on the top, and so it shouldn't be too difficult to assemble that. Now, there are two SMD components to assemble. There's a voltage regulator here, and there's a component just there on those two tabs. I don't think that's much to be afraid of, because they're relatively large SMD components, and we're going to put those on first, and I'll video that. The rest of it I'll move through quickly because it's just assembling a kit. But yeah, that looks all right, considering what this is and how much you pay for it. So I'm going to get set up with the soldering kit, and then we'll start with the those two SMD parts. Here's the circuit board then, and the two SMD components that need to go on. They're going to be going there and there. So first thing I've done here is I've cleaned the board with some isopropyl alcohol just to get all the grease off. In my experience, soldering is always better if things are clean. So although the circuit board obviously is new from the packet, there may be some residue from manufacturing, etc. So what I've done is put some flux paste onto the 4 pads there for the voltage regulator and the 2 pads there for the resistor. So what I'm now going to do is I'm going to take the component and I'm going to carefully place it in position as best I can, like so, and I'm hoping that the flux paste is going to sort of keep it in position on the board. I'm just going to move that resistor out the way for a while so I can work a little better. You can hopefully see what's going on here. Now I've got my soldering iron, and I've got it with the small size tip in. This is the soldering iron I built from a kit. There is a video about that. If I remember, I'll try and link that somewhere at the top for you. I've got 2 tips for this. This is the smaller of the 2, so it's nice and clean. It's got a little bit of solder on it. This is multi-core solder, So what I'm now going to do is just try and hold the part down and just let the solder flow where the flux is. That's the theory anyway. I'm hoping that'll happen. It doesn't seem to be happening right now. I seem to have just stuck the solder to the board. Maybe the tip is a little small for a large area. Right, that seems to have flowed now. Yeah, I'm just going to try and warm that up to reposition it a bit. It's been on there as probably about as long as I want it to be. Yeah, it is. Tip isn't really very big for this job. Okay, it's definitely in the right position, and I can see those three connections are still okay. So I'm going to go ahead and solder those. That should be a lot easier because they're much smaller. That's my excuse anyway. Yep, that one's gone nicely. I'm hoping that one will too. With a little bit more solder. Apologies if my head's in the way there. It's not easy filming and soldering. I know one or two YouTubers sometimes say that. Yep, that's flowed. So let's try and do the last one like so. It'd be so much better if I thought it had flowed. Yep, I think it has. I'm just going to check that with a magnifying glass to be absolutely sure, but I would say that's okay. So we'll just quickly solder the resistor on, which hopefully is going to be even easier because the pads are absolutely enormous for that resistor. Apologies if my head's in the way yet again. I can't see when I'm looking down whether it is or not. So I'm going to warm that pad up and try and run a bit of solder on and hope it's going to catch the resistor. I'm wondering if it might have been better to have put solder on the pad first. It may have been. And we'll try and do the second side now. Yep, that's flowed. Notice creative use of the solder there to hold the part down. I'm going to make sure this side's okay now. Probably the advantage of right, that shouldn't be moving, should it? This is not going to be a good video on how to solder SMD components. Dear me, that doesn't look good. What I'm going to do is actually measure the continuity. With nothing else on there, I'll be able to do that. So I'll see what they look like, and then we'll get on with the rest of the components. Okay, so two components I've checked with a magnifying glass and they look alright. I've cleaned up with some IPA. Here's a couple of close-up shots taken with a macro lens so you can see how they look. Be nice if that was in line, but it doesn't matter. That's a 0.02 ohm resistor. So I've had my LCR meter across these two connections here before there's anything else attached, and it does indeed check out, so I'm happy with continuity there, and hopefully that voltage regulator is going to be okay. So next job is going to be the wire-ended resistors. Now they're these blue coloured metal film resistors that Chinese folks seem so keen on. I don't like them because I find them quite difficult to read the colour codes. Maybe that says more about my age than anything else. Some are more obvious than others, so I always check using a meter before I put resistors on. But what's quite nice in this kit is the actual resistances values have been written on the ends here, on all of them actually, 2K2 there. So that's actually rather nice. I'm going to check that these really are that. I'm sure they are. In fact, I can see the colour codes on that one. I'm happy with that one, but I'm going to check anyway with the meter, and then I'll just put them in batches. The good news is I'm not going to video that. I'll come back when I've got those resistors installed. So by the magic of filmmaking, we'll install some resistors. That's the resistors fitted then. You can see there, I checked them all out, and values were indeed as written on the end pieces, and it's quite encouraging to discover that there was one spare resistor of each value. I was beginning to think I'd missed something, but I haven't. So that was I didn't have to do that. That was quite nice. So next is going to be the capacitors, these ceramics, some electrolytics, and then there's 2 diodes, an LED and 4 transistors. So I'm going to be fitting those next. Just to be aware that the 3 transistors here are the same. That one is a slightly different number. That's an 8550. These are 8050, so just be careful there. Don't make a mistake with your reading. Now these capacitors are supposed to be 100 nanofarads, marked up 104. Those two are actually marked up 10, but I think it's just the 4's missing. I've actually put them on my multimeter, and that was the result I got. So I double checked on the LCR meter, which pretty much agreed with what I was getting on a multimeter. So they're clearly half the value stated. So a quick glance at the circuit diagram here. These appear to be essentially capacitors that reduce noise around the digital circuit. So I'm going to just fit them and see how we get on. If I have a problem, I have got some 100 nanofarads I could fit, but I suspect they're going to work just fine like that. But it is a bit bizarre that they were only coming out at around about 50 N instead of 100. But there we go. Right, I'll come back when I've populated the board with these components. Okay, that's capacitors fitted, ceramic, electrolytic, ceramic up there as well. And I've now fitted the LED, the diode and the 4 transistors. That is the one that's the different number. That's the 8550. The others are all 8050s here. And I did incorrectly call this a diode earlier. It's actually a thermistor, and in the instructions it's shown as mounted just off the board. So I've mounted it sufficiently far off the board that if necessary I can shorten those leads, but we'll see. The only comment I'd make is that C3 here, the electrolytic, when you come to mount it, those 2 traces are quite close together. So I just got the magnifying glass out, and to be absolutely sure there wasn't a bridge there, I just ran the knife through. Here's a close-up photo of that. You can see that there isn't a bridge, so that's good. But that is something just to be aware of. Those traces were quite well, the 2 pads were quite close together. So I'm going to move on now to fitting what I'm going to call more of the hardware. There's the 2 displays, quite a lot of connectors, including the USB connector here. The good news is it's only taking 2 connections off the USB for power on there. So and also the buzzer and a few other bits. So I'll get those bits fitted. I'll get the IC sockets mounted, and then I'll show you what I'm doing. Okay, there's the board pretty much finished then. Sockets are on, LED displays are on, all the various connectors to multi-turn pots here. Pin header there and there. Just to be aware, this pin header here, which I think is to do with programming the microcontroller, doesn't have any pin header inserted there. That's just left. So yeah, that's the board pretty much ready. If you're already familiar with soldering, forgive me for teaching you to suck eggs, but when you're putting multi-pin sockets in like this one, and also, well, these for that matter, always a good idea to solder one connection and then perhaps the opposite end as well, so you can make sure that it is positioned okay, because it's much easier to adjust it when you've got a couple of things soldered rather than all of them. And a close look at some of the joints here and here, I can see that the solder has flowed, so I'm not too worried about that. So next job is to clean up the board with some isopropyl alcohol. But just before I do, I've not put the chips in yet. There's the op amp there and the micro here. I've got a 5-volt supply here, so I'm just going to plug that into the USB socket, which is indeed one of the reasons for supplying it, because what I want to do is I want to check some voltages, make sure everything is alright, particularly this surface mount regulator, which I didn't do the world's best job of soldering. I want to make sure that's okay. So I'm going to power up, and I'm just going to go to this socket here and check I've got something like 5 volts, and meters showing 5.2 volts there. Yep, so that's okay. So here I should have 3.3, and I have 3.275, so that's good. Should be 3.3 here. Yes, there is, and also here, which are the 2 power supplies for the 2 chips. So I would say that's working all right. The LED is lit, so clearly the polarity is okay there. So the next thing is I'm going to install the chips, but before I do that I'm just going to clean up the board, and I'll come back when I've got the chips installed. Okay, that's 2 chips installed now. That one was relatively straightforward. The micro has an awful lot of pins on it, so I had to very carefully just bend them in slightly to fit in the socket. So do be careful doing that, and remember to orient the notch in the correct direction. It's easy sometimes to fit the socket with the notch the other way around as well. I was careful to make sure I didn't do that. So we're ready for first power up, so let's switch on and hope we still get a red light and something on this display. Yeah, that looks good. So we've got displays here. I need to read the instructions to understand this, but let's see if we can tap through to temperature, and that's probably going to be the easiest way to test. So that's saying, I don't know how well it is to set, saying 24C. So I'm guessing that's that thermistor. So I'm going to grab that thermistor and see if we go up. Yep, going up to 28 there, 29. Don't know how well you can see that. It needs a little dark cover over it probably. But yeah, there we go. That's 29C, and then if I just blow across the thermistor, it cools down again. So clearly that bit's working. I'm going to need to get some instruments set up to test the other parts of the circuit, but that's looking good. So I'll come back when I've got it hooked up to the scope, and we can look at PWM functions, etc. Right, here's the kit then. Been running off a USB power supply, and I suppose the question I need to answer is, what kind of things will it actually do? Well, it'll do a number of things, and I suggest you, if you're really interested, you have perhaps a read of the online instructions. I'll make sure there's links in the description. But of course this microcontroller here is doing the heavy lifting, and when you power up like so, I've turned the bench light off, by the way. If I turn it on, you can't see the display, so I'm going to leave that off for now, and hopefully you can read the numbers reasonably well. So by default, when you switch on, it goes into voltage and current measurement. I've not got the current measurement set up, but it goes to that connector there. I'll just show you the voltage, just to where this video is already getting quite long. I've just got it attached to the bench power supply. If I go up to about well, the bench power supply, that's around about 6 volts. You can see the top display is rising up, and this display will do this power supply will do 15 volts. It's saying about 15.1. The unit's measuring about 15.3, so seems to be doing that reasonably accurately. One press on the button here moves into temperature mode, and we've already seen it, but just to prove the point, if I just put my finger on the thermistor, you can see it's climbing up there a little bit. Not going to get any more, obviously. That connector there allows you to connect an external thermistor, which would read out here. So you've got 2 lots of temperature reading. Third push takes you to a function that measures logic level, low or high. I haven't got that connected up, and I don't intend to show you that, but I think that's fairly self-explanatory. If we move to this is now measuring signal, and so signal frequency and duty cycle. So I've got it hooked up to my signal generator. So what I'm going to do is I'll just get to the frequency measurement, if I can find it here. So currently I'm at 50 Hertz. If I move smartly up to 100, you can hopefully see the top display is changing there. And let's move up in 100 Hertz steps. More than happy. Up to 500, well, the frequency generator saying 500, so it's a couple of hertz out. And if I go up to 1.2 kilohertz, you can see it's happy to measure up to there as well. I will put the spec in the description as well. But that's 2 kilohertz, and it's showing you there nicely. So I'm going to come back down to 400 hertz. And then if we start varying the duty cycle, currently we're at 50%, but if we, for some reason, it's not going to, there we go, yeah, right. That's because I'm in the wrong setting on the signal generator. But if you vary the duty cycle, then that follows, and actually that tracks pretty accurately. And the final thing I'm going to show you, and we'll bring the scope view up to see this, is it actually outputs PWM. Now it'll output it at 3.3 volts with the jumper there, and if I move that jumper onto the next one, it'll output it at the supply voltage. In this case it's 5 volts, but you can see I've got PWM, and then these two pots will adjust the frequency. So we can go up, and if you see I've got the scope measuring frequency there, so if I set that at 300 Hertz on the display, you can see it's about 298 according to the scope's measurement, so it's not doing too badly. Let's up that a little bit more. This is a multi-turn pot, that's why it takes so long. Let's try and get that to as near as I can to 1 kilohertz. Just carefully tweak the pot, and that's saying 1.1 kilohertz, and then duty cycle measures that pretty accurately actually. So if I go down to a 36% duty cycle, it's saying 35.7 on the scope. I think that's pretty good. And if we up it to, let's say, 60 somewhere, no, it's 160, it only wants just to give me 61 at 60.79. so yeah, the PWM output is pretty accurate as well, and you can adjust the amplitude between supply voltage or 3.3 with that jumper. Yeah, there you go. So that's some of the functions. I've not shown you all of them, but it gives you an idea of the kind of things it does. It's also got 3.3 volts out here, and you've also got another out that you could take to a breadboard if you wanted, which would be whatever the supply voltage is. So for a hobbyist wanting to have a go at building a kit and build something that allows him to sort of do something useful, yeah, it's all right. And I'm pleased to say it worked first time. So there you go, that's the IC Station Multifunction Kit. Quite impressed. Okay, there you have the IC Station Multifunction Production Kit. Hopefully it's made some sense now you've actually seen the thing. IC Station sent me that free of charge. I'll put a link in the description to the kit and also to the instructions. It's not an affiliate link, I make nothing from it, and other than getting the kit free of charge, that's my only connection with IC Station. So as I mentioned at the start, it's definitely a kit I think that's very much about the journey of construction as much as it is the finished article, and if you're new to electronics, it's probably quite an interesting thing to have a go at building. And I was right about the capacitors not making too much difference to the finished article, because it seems to work just fine. So hope you've enjoyed watching that. Thanks very much as ever for taking the time to watch the videos, and look forward to seeing you on the next one.